This is a lecture for Math 60, Section 4.2 on systems of equations and substitution. In the previous section, we talked about systems of equations and finding a common solution by graphing. We graphed each line, we saw if they crossed or not crossed or were the same line, and that was their common solution. But they don't always graph in real nice sweet spots, and even if they intersected, you can't always tell exactly where that point of intersection is. So it's really nice to be able to have another method. So we're gonna take a look at a step-by-step process on the next page, but rather than do that first, I think it just makes more sense if I go through a few examples. So I'm sorry I'm kind of doing it like this, but I tried the video and it didn't work, and so I'm having to do it again. So just kind of bear with me. This is the system right here. These two equations, x plus y equals 5 and y is equal to x plus 3. Now, the way this is set up, it's really kind of nice because in this particular equation, the y is already isolated. So what I'm going to do is first I examine the equations, and I like this guy right here because the y is already by itself. So what I'm going to do is I'm going to take its equivalent, this guy right here, and I'm going to plug it in for y in the other equation. So instead of it saying x plus y equals 5, it's now going to say x plus 3 equals 5. Well, I've created an equation with one unknown, and that I can solve. So I combine the x's. Parentheses really don't play a role here. I add the x's together, throw the 3 on the other side. I end up with 2x is equal to 2. Divide both sides by 2, and I get x equals 1. That's the first part of my answer. That's the x component. Now what I have to do is I have to take this and I can plug it in either equation, either one. I elected to use this guy right here, x plus 5 plus y equals 5. So instead of x, I put a 1 in. 1 plus y is equal to 5, and I solve for y by putting the 1 on the other side, and y equals 4. And there's my answer, 1, 4. There's my x component and my y component. And I can easily check them by putting these in here, and sure enough, they add up to 5. And if I put them in here, if I put the 1 in here, 1 plus 3 is 4, and so it's a good solution. So let's take a look at this next guy. The difference between him and him is that the y, or the x, is not isolated here. And I need to do that in order for me to do the substitution. So I really like this guy here. Because there's no coefficient in front of the y. So that's the one I'm going to work on first. So I'm going to take this 2x and throw it on the other side. So here's my starting point. I took the 2x and put it over here, and I ended up with y is equal to 2x minus 6. Now what I'm going to do is take this guy here, which is equal to y, and put him in right there in the other equation. So here's the other equation. 2 times, and instead of y, it's going to say 2x minus 6. I'm going to go ahead, and I copied the rest of it down. I went ahead and did the distribution, so I get a 4x minus 6. There's my minus 5 equals, or minus x equals 5. Put the x's together, and I end up with 3x. Take the 12 and throw it on the other side, 17. Divide both sides by 3, and I end up with x is equal to 17 over 3. Not a pretty number, but it's not too scary either. Now I'm going to take that value. There's my first answer, the first part of my answer. I'm going to take that value, and I get to put them in either equation, either one. And I chose the first one. So there's the first equation. And then I went ahead and put 17 over 3 in for x, just substitution. And then I multiplied that by 2, which is what, so now I have y minus 34 over 3 is equal to negative 6. I'm going to take this and throw it over on the other side, and he becomes positive. There's my minus sign. And instead of me writing down 6, I know it has to have a denominator of 3, so I'm going to change it to thirds, so it's 18 over 3. I do the subtraction, I get 16 over 3. There's the second part of my answer. So here's the y part, or excuse me, the x part, and here's the y part. To check it, I went ahead and used the first equation. I put 16 over 3 in place of y minus 2 times x. 2 times 17 over 3 is 34 over 3 is equal to that. I did the subtraction. I have negative 18 over 3 is equal to negative 6, and indeed they are the same. And I went ahead and checked it in the other one. 2 times y, 2 times 16 over 3 minus 17 over 3 is equal to 5. I multiplied these together and I got 32 over 3 minus 17 over 3. I subtracted and got 15 over 3, and that indeed is equal to 5. So I'm really, really, really confident that my answer is correct. In the next example, rather than just have a problem where the equations are given to you, you have to come up with the system of equations. And you are going to be tested on this sort of thing on your final, so it's really good to pay close attention. It says two angles are supplementary. Well, you have to know what supplementary angles are. And all it means is that if I have two angles, like angle A and angle B, that they add up to 180 degrees. And that's shown here. Here's an angle A, call it an angle B, and together they form a straight line. So whenever you have two angles that are that their sum is 180, we call them supplementary angles. And then it says that one of the angles is 15 degrees more than twice the other. And our job is to find the measure of each angle. So the first thing I'm going to have to do is define some variables. So I said let x equal the first angle. Let x, and I don't know which one is the first, but I'm going to have x equal the first. And the second one, the second angle, I'm going to use a different variable. I'm going to say let y equal the second angle. Okay, so I defined my variables. That was pretty easy. Now I'm going to go ahead and use the information that's given to me. It says they're supplementary. Well, if they're supplementary, then I know that they add up to 180 degrees. So that's my first equation. The second part, it says that one of the angles is 15 degrees more than twice the other. So one of the angles, I'll call it x, is equal to 15 degrees more, there it is right there, than twice the other, 2 times the other angle. So this is the other angle. Here's my system. I just created a system. And now I can solve it just like I did the other problems. So I think what I'll do is, because the x is already isolated here, I'm going to take the value for x and I'm going to plug it in right there, right there. So here it is, 2y plus 15. Plug that in for x. I can even put it in parentheses if that'll help you see it. And then I copy down the rest. And now I combine my y terms. So I have a 3y. And at the same time, I'm going to go ahead and throw the 15 on the other side, which gives me 165. Divide both sides by 3, and I get y equals 55. So I just found the first part of my ordered pair, the y value, right there. And now I'm going to take that value and I get to plug that value into either one of these guys. And I chose to use the first guy. So here he is, x plus y is equal to 180. I take y and I take my y value, 55, and I substitute it in. So there he is, x plus 55 is equal to 180. Take the 55, throw it on the other side, and I get x equals 125. And that's the second part of my answer. To check, I can look at these two guys. Do they add up to 180? You bet they do. And I'm going to check in the other one, and I did that over here. 2 times 55, 2 times the y value is 110. And if I take that 110 and I add 15 to it, I get 125, which is the same as the x value. So that's good. Here is the step-by-step process. It says to solve using substitution method, solve for a variable in either one of the equations. So you're going to you set up your equations if they're not already set up, and you look them over and you decide which one you want to work with, and then when you decide that, you decide which variable do I want to isolate. Once you've decided that, you take the result of that and you put it in the other equation and then solve that other equation. And once you get a solution for either your x component or your y component, you take that and you substitute it into one of the into the other equation, or you could put it in the same one to solve for the other variables. When you're done getting the second component, you check to make sure that your answers are correct, and you should be pretty confident in your answer. So this is a substitution method, and it's a lot easier than graphing all the time. That's it.